A Red Cross helicopter takes off from headquarters and flies 100 kilometers in the direction of south 65 degrees west. So we're going to draw that off from south. We need to swing around to the west by 65 degrees. So here's our first vector, and its length is 100. It drops off some relief supplies and then flies 80 kilometers at north 70 degrees west to pick up 3 medics. Alright, so the next thing we're going to do is we're going to measure off from north, and we are going to move from north 70 degrees to the west. We swing around here by 70. So this is 70, and that travels 80 kilometers, so that's the length of that vector. If the helicopter then heads directly back to headquarters, find the distance and direction it should fly. So going directly back to headquarters, we've got a vector that goes across here, and we want to know its length, and then we're going to need to know an angle for its direction. So as I look at this, these 3 vectors make a triangle, and I have a side 80 and a side 100. I don't have the angle. I do have 70 degrees if I can find out this other angle, and I can because this is north and south. They're parallel. They're cut by this transversal, so this alternate interior is 65, and the one over on the other side down here is also 65. So now I have an angle, and I have side angle side, and I can use the law of cosines to find that side length x. So let's do that. That side squared, x squared, equals the sum of the squares of the other 2 sides, which is 80 squared plus 100 squared minus 2 times the product of those 2 sides, 80 times 100, times the cosine of the angle between those 2 sides. Well, I can add these 2 together, and that angle is 135 degrees. So I go ahead and I put that in the calculator, and then I get that totaled, and that is x squared. So I need to square root that answer to get x, and it looks like x is 166.5 kilometers. So that's the distance to get back to headquarters. Now I need to give a direction, and we know directions are measured off north and south. And if I look here, I have the line I just drew and the north line over here and a transversal. So since that angle's 70, this angle right here is also 70. Now if I find this angle in the triangle, I'll call it alpha. Then alpha and 70 and this angle I'll call theta make up a straight line of 180 degrees, and theta will be my direction angle. So let's go to the triangle first, and we're going to find alpha. And so I'm going to use the law of sines because I have an angle side opposite a pair now. And so I know that the sine of 135 over the side opposite, I'm going to use the value in my calculator that's not rounded, but I'll write down here my rounded value. That was 166.5 equals the sine of alpha over the side opposite it, which is 100. So I can multiply the 100 over here and get my calculator and do inverse sine of 100 sine 135 degrees divided by 166.5, but I'm just using the answer that's already in my calculator so I don't lose accuracy in rounding. And that looks like that tells me that alpha is 25.1 degrees. So if alpha is 25.1 degrees, I know that those and theta make up a straight line. So if I do 180 minus the 70 minus the 25.1, that will tell me theta. And it looks like that is 84.9 degrees. So now the direction angle, if I measure off from north around to the east, I have north 84.9 degrees east is the direction that the helicopter would need to travel. Now another way to say that in words is it is 84.9 degrees east of north.